Process selection and execution. In non-preemptive priority scheduling, the highest priority runs until completion. Even if higher priority ones arrive, CPU idle. The CPU is initially idle waiting for the first process to arrive. Highest priority process selected. When a process arrives, the scheduler selects the process with the highest priority and assigns it to the CPU. Process runs to completion. The selected process runs to completion without interruption even if other processes with higher priority arrive during its execution. Practical implementation and Gantt chart. To illustrate the concept of non-preemptive priority scheduling, let's consider a scenario with 5 processes as shown below. Gantt chart construction. How to create a Gantt chart. A Gantt chart visually represents task scheduling over time. For priority scheduling, it shows process executed by priority. To make the Gantt chart, identify process and their priorities, then plot them in a priority order with their burst times. Process 1 P1 starts execution at time 0 with a priority of 3. It runs until 2 when it preempted by process P2, which has a higher priority. P1 remains in the ready queue and resumes execution at the time 15 after higher priority process finish, completing at time 23. Same for the process 2, then process 3, after that process 4, and then process 5. Arrives at time 8 with the lowest priority is equals to 5. It waits until all other processes are done and finally starts at time 27, completing its execution at time 33. Performance metrics. To evaluate the priority scheduling, we use metrics like completion time, turnaround time, and waiting time. These shows how well the scheduler manages processes and optimizes performance. Let's calculate these for example scenario to understand the impact of priority scheduling. Diagram explanation. To visualize process execution and performance metrics, we can use a diagram. P1 starts at time 0 but is preempted by P2 higher priority at time 2. P2 runs from 2 to 7, completing before P3 starts at time 7. P3 runs from 7 to 15, after which P1 resumes and completes at the time 23. P4 arrives at time 6, runs after P1 from time 23 to 27. Finally, P5 runs from 27 to 33. Completion time. The time at which process finish execution, turnaround time, the time difference between a process's arrival time and its completion time. Waiting time. The time of a process is spent waiting in a ready queue before being assigned to the CPU. That's all for today. Thank you.